Book 5, Chapters 10 to 12 of 10 books on architecture. This LibriVox recording is in the public domain. Recording by Fredrik Karlsson. 10 books on architecture by Vitruvius, translated by Morris Hickey Morgan. Chapter 10. Baths. 1. In the first place, the warmest possible situation must be selected, that is, one which faces away from the north and northeast. The rooms for the hot and tepid baths should be lighted from the southwest, or, if the nature of the situation prevents this, at all events from the south, because the set time for bathing is principally from midday to evening. We must also see to it that the hot bathrooms in the women's and men's departments adjoin each other, and are situated in the same quarter, for thus it will be possible that the same furnace should serve both of them and their fittings. 3 bronze cauldrons are to be set over the furnace, one for hot, another for tepid, and the third for cold water, placed in such positions that the amount of water which flows out of the hot water cauldron may be replaced from that for tepid water, and in the same way the cauldron for tepid water may be supplied from that for cold. The arrangement must allow the semi-cylinders for the basins to be heated from the same furnace. 2. The hanging floors of the hot bathrooms are to be constructed as follows. First, the surface of the ground should be laid with tiles 1.5 feet square, sloping towards the furnace in such a way that, if a ball is thrown in, it cannot stop inside, but must return of itself to the furnace room. Thus the heat of the fire will more readily spread under the hanging flooring. Upon them, pillars made of 8-inch bricks are built and set at such a distance apart that 2-foot tiles may be used to cover them. These pillars should be 2 feet in height, laid with clay mixed with hair, and covered on top with the 2-foot tiles which support the floor. 3. The vaulted ceilings will be more serviceable if built of masonry, but if they are of framework, they should have tile work on the underside, to be constructed as follows. Let iron bars or arcs be made, and hang them to the framework by means of iron hooks set as close together as possible, and let these bars or arcs be placed at such distances apart that each pair of them may support and carry an unflanged tile. Thus the entire vaulting will be completely supported on iron. These vaults should have the points on their upper side daubed with clay mixed with hair, and their underside, facing the floor, should first be plastered with pounded tile mixed with lime, and then covered with polished stucco in relief or smooth. Vaults in hot bathrooms will be more serviceable if they are doubled, for then the moisture from the heat will not be able to spoil the timber in the framework, but will merely circulate between the 2 vaults. 4. The size of the baths must depend upon the number of the population. The rooms should thus be proportioned. Let their breadth be 1/3 of their length, excluding the niches for the washbowl and the bath basin. The washbowl ought without fail to be placed under a window, so that the shadows of those who stand round it may not obstruct the light. Niches for washbowls must be made so roomy that when the first comers have taken their places, the others who are waiting round may have proper standing room. The bath basin should be not less than 6 feet broad from the wall to the edge, the lower step and the cushion taking up 2 feet of this space. 5. The laconium and the other sweating baths must adjoin the tepid room, and their height to the bottom of the curved dome should be equal to their width. Let an aperture be left in the middle of the dome, with a bronze discharging from it by chains. By raising and lowering it, the temperature of the sweating baths can be regulated. The chamber itself ought, as it seems, to be circular, so that the force of the fire and heat may spread evenly from the center all round the circumference. Chapter 11. The Palaestra. 1. Next, although the building of palaestrae is not usual in Italy, I think it best to set forth the traditional way and to show how they are constructed among the Greeks. The square or oblong peristyle in the palaestra should be so formed that the circuit of it makes a walk of 2 stadia, a distance which the Greek called diaulos. Let 3 of its colonnades be single, but let the 4th, which is on the south side, be double, so that when there is bad weather accompanied by wind, the drops of rain may not be able to reach the interior. 2. In the 3 colonnades construct roomy recesses with seats in them, where philosophers, rhetoricians, and others who delight in learning may sit and converse. In the double colonnade let the rooms be arranged thus: the young men's hall in the middle. This is a very spacious recess, etc., with seats in them, and it should be 1/3 longer than it is broad. At the right, the bag room, then next the dust room, beyond the dust room, at the corner of the colonnade, the cold washing room, which the Greeks called loutron, At the left of the young men's hall is the anointing room, then, next to the anointing room, the cold bathroom, and beyond that a passage into the furnace room, at the corner of the colonnade. Next, but inside and on a line with the cold bathroom, put the vaulted sweating bath, its length twice its breadth, and having at ends on one side a laconium, proportioned in the same manner as above described, and opposite the laconium the warm washing room. Inside the palaestra the peristyle ought to be laid out as described above. 3. But on the outside let 3 colonnades be arranged, one as you leave the peristyle, and 2 at the right and left, with running tracks in them. That one of them which faces the north should be a double colonnade of very ample breadth, while the other should be single, and so constructed that on the sides next the walls and the side along the columns it may have edges, serving as paths, of not less than 10 feet, with the spaces between them sunken, so that steps are necessary in going down from the edges 1.5 feet to the plane, which plane should be not less than 12 feet wide. Thus people walking round the edges will not be interfered with by the anointed who are exercising. 4. This kind of colonnade is called among the Greeks xystos, because athletes during the winter season exercise in covered running tracks. Next to this xystos and to the double colonnade should be laid out the uncovered walks which the Greeks term paradromides, and our people xysta, into which, in fair weather during the winter, the athletes come out from the xystos for exercise. The xysta ought to be so constructed that there may be plantations between the 2 colonnades, or groves of plane trees, with walks laid out in them among the trees, and resting places there made of opus signinum. Behind the xystos a stadium so designed that great numbers of people may have plenty of room to look on at the contest between the athletes. I have now described all that seemed necessary for the proper arrangement of things within the city walls. Chapter 12. Harbours, breakwaters, and shipyards. 1. The subject of the usefulness of harbours is one which I must not omit, but must explain by what means ships are sheltered in them from storms. If their situation has natural advantages, with projecting capes or promontories, which curve or return inwards by their natural conformation, such harbours are obviously of the greatest service. Round them, of course, colonnades or shipyards must be built, or passages from the colonnades to the business quarters, and towers must be set up on both sides, from which chain can be drawn across by machinery. 2. But if we have situation without natural advantages, and unfit to shelter ships from storms, it is obvious that we must proceed as follows. If there is no river in the neighbourhood, but if there can be a roadstead on one side, then let the advances be made from the other side by means of walls or embankments, and let the enclosing harbour be thus formed. Walls which are to be under water should be constructed as follows. Take the powder which comes from the country, extending from Cumae to the promontory of Minerva, and mix it in the mortar trough in the proportion of 2 to 1. 3. Then the lower surface inside, under the water, must be levelled off and dredged, working from beams laid across, and finally concrete from the mortar trough, the stuff having been mixed as described above, must be heaped up until the empty space which was within the cofferdam is filled up by the wall. This, however, is possessed as a gift of nature by such places as have been described above. But if by reason of currents or the assaults of the open sea the props cannot hold the cofferdam together, then let the platform of the greatest possible strength be constructed, beginning on the ground itself or on a substructure, and let the platform be constructed with a level surface for less than half its extent, while the rest, which is close to the beach, slopes down and out. 4. Then, on the water's edge and at the sides of the platform, let marginal walls be constructed, about 1.5 feet thick, and brought up to a level with the surface above mentioned. Next, let the sloping part be filled in with sand and levelled off with the marginal wall and the surface of the platform. Then, upon this level surface, construct a block as large as is required, and when it is finished, leave it not for not less than 2 months to dry. Then cut away the marginal wall which supports the sand. Thus the sand will be determined by the waves, and this will cause the block to fall into the sea. By this method, repeated as often as necessary, an advance into the water can be made. 5. But in places where this powder is not found, the following method must be employed. A cofferdam with double sides, composed of charred stakes fastened together with ties, should be constructed in the appointed place, and clay in wicker baskets made of swamp rushes should be packed in among the props. After this has been well packed down and filled in as closely as possible, set up your water screws, wheels, and drums, and let the space now bounded by the enclosure be emptied and dried. Then dig out the bottom within the enclosure. If it proves to be of earth, it must be cleared out and dried till you come to solid bottom and for a space wider than the wall which is to be built upon it, and then filled in with masonry consisting of rubble, lime, and sand. 6. But if the place proves to be soft, the bottom must be staked with piles made of charred alder or olive wood, and then filled in with charcoals as has been prescribed in the case of the foundations of theatres and the city wall. Finally, build the wall of dimension stone with the bond stones as long as possible, so that particularly the stones in the middle may be held together by the joints. Then fill the inside of the walls with broken stone or masonry. It will thus be possible for even a tower to be built upon it. 7. When all this is finished, the general rule for shipyards will be to build them facing the north. Southern exposures from their heat produce rot, the woodworms, shipworms, and all sorts of other destructive creatures, and strengthen and keep them alive. And these buildings must by no means be constructed of wood for fear of fire. As for their size, no definite limit need to be set, but they must be built to suit the largest type of ship, so that if even larger ships are hauled up, they may find plenty of room there. I have described in this book the construction and completion of all that I could remember as necessary for general use in the public places of cities. In the following book I shall consider private houses, their conveniences and symmetrical proportions. End of Book 5.